Okay, Bismillahirrahmanirrahim. So this is secant method, the final subtopic, the final method under subtopic roots of nonlinear equation. Okay, all right. So similarly as Newton-Raphson, the secant method also has its particular formula, where the formula is actually derived based on the Newton-Raphson as well, where it's more simplified, where you don't have to do differentiation in order to use the formula. Right. So you have to understand, again, I repeat, the objective of using secant method is because you want to know the value of x, which is the solution of the fx. Okay. So example 1. Solve x squared plus 2x minus 5 using secant method with initial value x0 and x0 equal to 0 and x1 equal to 1. Use 4 decimal places in all calculation. Alright, first of all, you can see here obviously that for Newton-Raphson, for secant method, we have to have two initial value. Okay, bisection also required two bisection. Newton-Raphson required one initial value only, but secant again required two initial value in its implementation. Right, this is the formula of secant method. Okay, so as usual, I always encourage students to present your answer in a table. So in this table, what you have to put in the column, in the first column, of course, is the I. The second column is the xi. The third column is if is fxi. So compared to the Newton-Raphson, we have four column. The column number 4 is the f prime, but we don't require it in the formula, so just stop at the fxi. Alright, so start with the iteration 0. So what is x0? Given in the question is 0. Okay, so x0 is 0. And then fx0, you substitute 0 into fx, you will get negative 5. Obviously, substitute 0 into fx, okay, you will get, substitute 0 into fx, you get negative 5. And then for iteration 1, also you have the initial value x1 here given in the question. So it is 1. Substitute 1 into fx, you will get negative 2. Okay, just use your calculator, don't worry. For iteration number 2, now you have to apply the formula. So you want to know x2, you will use x1 minus fx1 multiply with x1 minus x0 divided by fx1 minus fx0. Okay, I just based on the formula given. So it means that x1 is equal to 1 minus fx1 is negative 2. X1 is 1 minus x0 is 0. Okay, divide by fx1 is equal to negative 2. Fx0 is negative 5. Okay, so it is equivalent to 1.6667. Okay, then substitute 1.667 into fx, you will get 1.1111. Continue to iteration number 3. Remember, when you have to stop, when you reach x0 equal to 0, because we don't have condition of the epsilon. Okay, so you have to do the iteration, you have to continue the iteration, you have to solve using the formula until you get fx equal to 0. Alright, so now similarly, to get x3, it is 1.6667 minus with the 1.1111, which is fx1, multiply with the x1, which is 1.6667 minus with the 1, which is x1, divided by fx2, 1.1111 minus with the negative 2, which is fx1. So the answer is 1.42 0.86. Okay, be careful when you applying the formula, when you use your calculator. Please be careful. Okay, then substitute into the fx, you will get negative 0.1020. Then continue your work. Okay, this one you use x3 and x2 as you substitute into the formula, you get 1.4486. Substitute into fx, you will get negative 0.0044, and then continue more for iteration 5, you will get 1.4495, and substitute in fx, you get 0.0000. So now you can stop because the fx is already equal to 0. If you remember, if you remember, this question actually similar as the question in the Newton-Raphson. Example 1 in Newton-Raphson. You can check later on. Okay. In Newton-Raphson, if I'm not mistaken, it does involve 3 iteration. But in secant method, it involves until 5 iteration. Iteration number 5. So in secant method, it looks like involve more iteration, but actually it's simpler than the Newton-Raphson because in Newton-Raphson you have to do differentiation, and then it's involved a few calculation of x, fx, and also f prime. Okay, so for me, in my opinion, secant is better in terms of computational time. Okay, it's involved, even though it's involved more iteration, but the calculation is simpler than the Newton-Raphson. It's up to you. It depends on your opinion actually. Okay, you can read in detail in internet, in the books, what they say about secant and Newton-Raphson. Which one is better? Which one is faster? Okay, so it's on you. Okay, you can find your own reason, your own source. Okay, all right. Okay, this example, actually I want to share with you how you going to determine the initial value if it is not given in question. It happens, okay? Sometimes question does not provide you the initial value. So what you have to do, okay, let's say for this question, solve for x cos 2x minus x minus 2 squared in the interval 0, 5 using dissection, Newton-Raphson and secant method. Okay, you are given a big interval actually 0, 5. Okay, in this case, what you have to do is you have to apply intermediate value theorem. Okay, remember in my first video, I introduced you what is intermediate value theorem, where if you have fx continuous in between an interval AB, if FA and FB have different sign, or FA and multiply with FB is less than 0, then at least the solution exists between A and B. So what happened is, for this question, you start by providing this table. This table I call as a sign table. Okay, I already show you how to provide this, how to do this table in this video number 1. So the interval is 0 to 5. So 0 to 5 here, x is 0 to 5. Okay, and then fx, by substituting the value of x into fx given in the question. Okay, remember class, usually if the question, the function given is in terms of trigonometry like this, for example we have cos trigonometry, my suggestion is you have to use radian mode in your calculator. Okay, use radian in the calculator, and then you determine the sign of the fx. This is negative, negative, negative. This is so easy. Okay, so what you have is, you have to, based on intermediate value theorem, different sign. Where is different sign? You have here 1 and also here. Okay, so means that two interval is obtained from the from the interval 0, 5. We have subinterval, which is 2, 3, and 3, 4. Means that there exists at least one solution between interval 2, 3 and also 3, 4. Okay, so if let's say you are asked to use bisection method to solve this problem, you have to come up with two table, of course two table, bisection, Newton-Raphson, and secant method. you have to come up with two tables, where table 1 but based on the interval 2, 3, and table 2 based on the interval 3, 4. Okay, so by using bisection method, B is bisection method. Okay, bisection method, of course, this is very easy. The initial value, of course, straight away from the 2, 3. So this A, this is A, this is B. Similarly for this one, 3, 4. This is A, this is B, straight away from here. Using secant method, SM is secant method, you can choose x0 as 2, x1 which is 3, very easy. Similarly for table number 2, x0 equal to 3, x1 will be equal to 4. So you have different answer from table 1 and table number 2. Okay. For Newton-Raphson method, if you remember, Newton-Raphson just required one initial value. So what you have to do from the interval 2, 3, you can choose any value as long as it's in between 2 and 3. For example, you can use x0 as 2 or x0 as 3 or any value. For example, 2.5. Okay, x0 is 2.5 as long as the value is in between the interval 2 and 3. So similarly for this table, x0 can be taken as 3, or x0 can be 4, or x0 can be 3.9, for example. Okay, all right. So I think that's all for the roots of nonlinear equation, first subtopic of numerical methods. Please do the tutorial. Any question, you can contact me, or we can discuss in detail during our lecture. That's all. Thank you. Assalamualaikum.